Okay, so here, and then you just flip it over. Hopefully it doesn't leak. So it doesn't leak. So you're good to go. So we're going to need, well, usually you're going to use a ring stand because you're going to rest it on a ring stand to sit like that. So it's kind of leaking a little bit, but that's okay. So the whole purpose of an extraction funnel is to be able to separate the two mixtures in a orderly fashion. So here's my hexane with iodine. Notice the two layers, okay? That's what I mean immiscibility. The hexane does not dissolve into water and vice versa, okay? Some water always will dissolve into some organic solvents. Actually, I take that back. And that's the purpose of the magnesium sulfate. You'll read about that in your manual. You usually add some magnesium sulfate to remove the water from your organic. All right. So the whole idea is that you'll have these two compounds mixed together. And so we're going to take advantage of the fact that if you add sodium hydroxide to the mixture, these are going to be an ether probably, some organic or methylene chloride, doesn't matter which one, and some organic solvent, okay? So you dissolve those two, you add sodium hydroxide, what do you think is going to happen? If you add sodium hydroxide to a mixture of these two, what is going to happen? What chemistry is going to happen? Acid-base chemistry, okay, so what does that mean? What's that? Of what? Of the carboxylic acid, right? The sodium hydroxide is strong enough base to remove the proton from the carboxylic acid, and so you're going to get the sodium salt of the carboxylic acid. That sodium salt of the carboxylic acid is going to be soluble in water, whereas the aniline, oh my gosh, I'm running out of markers here. Whereas the aniline is not going to be soluble in water, it's going to stay in the organic. Okay, and so on page 14 of your manual, or 18 of your manual, you have a separation diagram. So this is what I expect you to be able to draw if I ask for a separation diagram. So you add sodium hydroxide in the aqueous and then the organic. In the aqueous, you're going to have your salt of the carboxylic acid, okay, plural. And in the organic, you're going to have the aniline untouched, okay? So let's pretend that the blue is going to be your carboxylic acid fraction, and then the purple is going to be the aniline. So and it won't be, obviously it won't be colored, okay? You'll see probably a very thin line where the two solvents are immiscible, where there's just a separation. The whole idea is then to put them into a set funnel. The proper technique is to put your hand over this. Some people do this, it's okay, but the proper technique is to do that, and then flip it over and immediately vent it. Okay, the purpose is, usually when you mix solids together, there's going to be a buildup of pressure, so as soon as you flip it over, you vent it, so you relieve pressure, and then you close this, and this is kind of tight, so you know, some of yours might be tight. And then to do the extraction process, it's just like doing a martini. You're doing this, okay? You do this for a little bit, and then you stand it up, and that's why you need a container just in case things drip. And what will happen is, in the process of doing that mixing, what was in the organic is going to go into the aqueous. It's a salt, right? Okay? So let's say it'll do that. So now the design of this extraction funnel is such that you can go and drain out the bottom. Like that. You drain out the bottom. You've got the clean aqueous fraction, and then you drain from the top into another container. You drain your other fraction, and there you have it. You've separated the two layers. Okay. You will read in your manual when they talk about the extraction, and they do some mathematical calculations on how much you can get out of each extraction, and that depends on how good a solvent you're working with. Okay, for our purposes, we're going to be working with ether or methylene chloride to do the extraction as our organic phase, and then usually water, okay, sodium hydroxide or acid. So once you've separated, you can. The whole idea behind multiple extractions is if you do it once, you're going to get X amount of material out, right? So if you want to, let's say this is my organic, and so I think that there's more of my acid or my salt in there, I pour it back in here, okay? And I would add fresh sodium hydroxide, small amount, like 10, 15 milliliters. I would add it, okay? And then I would shake, again, flip it over, bend it, see how that kind of creates a little, and then you just shake it again. I'm extracting, and then I let it flip over. Each time I do this, I'm extracting whatever's, oops, and sometimes you don't want to let it go too far. But each time I do that, I'm continuously extracting what's in the organic phase into the aqueous. So let's say the first time I do the extraction, I get, 25% of the material out. If I add more sodium hydroxide, I do the extraction again, I get another 25%. So if I do that multiple times, I keep getting more and more material out, and there's a law of diminishing returns eventually. Okay, you can only do so much organic, and then you got everything out, or 99% of everything out. Okay, so usually if you do 2-3 extractions, you're pretty much guaranteed to get everything out, or most everything out. It's better to do, like I said, 2 or 3 extractions using, let's say, 20 milliliters of ether versus doing one big extraction using 60 milliliters, because of the solubility of your compound in the ether or in the water. It's going to be limited. So it's better to do small extractions and then collect several small fractions. That way you're assured of getting a complete separation. Okay. So once you have it in your separate containers, obviously you can do whatever you need to do. So for example, if I did the separation, I wanted to get the iodine out or something, I just evaporate off the solvent, and then the iodine would be left behind in my flask, and that's what you're going to do with this guy here. So I believe the aniline, I forgot what the other, what are you going to do with the aniline? I think you just evaporate it, right? Yeah, okay, so what you're going to do is once you've separated, you'll have your aniline in the organic phase, you'll have the carboxylic acid in the aqueous phase, and then what you do is you'll transfer this, and this will be in an Erlenmeyer flask. You'll wash it with some distilled water, I think, or with some water, just to remove any sodium hydroxide. So the washing is basically taking your organic layer, putting it back into the separatory funnel, okay, and you add clean water to it. That's the washing step. So after you've done your extraction, let's say the aniline is going to be in the organic layer, you want to wash it with clean water at least 2 times. So then you add about an equal amount of water. Okay, so you would add, well, let me just add some water to this and I'll show you. Oops. So you would add some water to your organic layer, and the washing is just to remove any sodium hydroxide that might be in there. So you just, again, the same technique, flip it over, don't point it at yourself or anybody else, and then shake like that, and then flip it over. So what you're doing is you're washing away from the organic, you're washing away any residual sodium hydroxide, and then you'll have a waste beaker or container where you can drain the waste into. And you'll have a ring stand in order to do this, so you won't be holding it with your hand. Okay, and then there you go. And then you transfer your organic back into a clean Erlenmeyer. You'll add some magnesium sulfate. Magnesium sulfate, MgSO4, is a white free-flowing powder that is very absorbent of water. So if you add magnesium sulfate to your organic phase, it'll suck up the water, okay? And it'll dry your organic, and then what it says is to filter it. And so you're going to filter that solvent into we'll do this for example. So you'll have a bigger flask, and we're gonna do a we're gonna use the machines back there. Those machines are basically distillation machines. Okay, so that's gonna just remove the solvent. So what you do is you set up a filtration where you'll have filter paper in a funnel, and you'll filter out the magnesium sulfate in that way, and then you'll filter your solution into a tiered round bottom flask, and then we'll put it on the rotary evaporator, and what that does is it goes under vacuum, and you heat it up, and it'll pull out the solvent. So it's basically a distillation apparatus. So rather than setting up a distillation apparatus to remove the solvent, you do it on the machine over there. So that removes the ether, and you'll have your product in your flask. And then you can go and weigh it, get a yield on it, a crude yield, and then I think what you're going to do next is you're going to recrystallize it. I believe that's what you're doing. I'll have to check. But if not, I'll make you recrystallize it anyway. I'm not sure how to do that. But that way you've separated your aniline from your carboxylic acid. The carboxylic acid, what you'll do next is it'll be in a Erlenmeyer. You'll add some HCl to it. When you add HCl to it, what's going to happen? It's going to protonate again, and the carboxylic acid will precipitate out. It'll crash out of solution. You'll see it. Okay? You'll wash it with some water, and then we'll let it dry. And I think we're going to do some melting point on that to check the purity. I think it might even have recrystallized, but let me go check. Okay, we're not going to recrystallize, but we're just going to separate them and dry them, and then take melting points to see how close we are to the actual compound. All right, so that's pretty much what's going to happen. And a lot of people get bogged down in that when it says use 20 milliliters of water and 20 milliliters of ether. I see them over there measuring out in a graduated cylinder, 20 milliliters. No, don't. All you have to do is just get some water and some ether in some clean beakers or Erlenmeyers, label them accordingly. So if you need to use 2 or 3 fractions of ether at 20 milliliters each, so you get about 60 ml, and then just eyeball it. You don't have to be measuring exactly, okay? Things not to do. You don't do this, okay, while you're talking to your friend. All right? Pay attention to what you're doing, okay? Just proper technique. Why? Because this is a laboratory class, and you have to learn proper technique. Yes, doing this accomplishes the same job, but it's not proper technique. Okay, because if you're doing this and talking to someone, you're not being a good researcher. Okay, you're just being a student who wants to get the heck out of class as soon as they can. Okay, so pay attention. Be zen. Watch. Think about what's happening on a molecular level. Okay, you're watching little molecules in there separate and go into different layers. So at least that'll keep you entertained. Any questions? Questions, comments? No? All right. So that's pretty much the spiel for this stuff. Come prepared with a pre-lab next week for your extraction, and we'll give you your compound, your benzoic acid, and your aniline. All right. Okay. So I'll grade these quizzes, and I'll hopefully have your lab reports back to you by next Monday, because now as of Friday I'll be free of LACC duty, so I'll get to do your stuff. But questions, comments about anything? The GC, we'll see what's going on in here. Okay, let's see. ARPA? All right, it's not printing the integration part, so we're having problems with that. All right, so there's really no point for them staying here. All right, so leave your labels S1, S2, F1, F2. And let's put them into separate containers. One container for S1, F2, one for F1, F2. Okay? And we'll try to run these things for you. I don't know what happened. They messed up the computer again yesterday, so I had it running perfectly yesterday.